All electric power consumed on board a ship is produced by onboard generators. Electric power is transmitted from the generator to electrical switchboards that distribute it to a variety of installations and equipment on board the vessel. Electrical switchboards are dedicated to cableway opening, closing, surveillance, control, and protection. They are the heart that ensures stable and safe distribution of power throughout the ship. This DVD will help you to understand switchboards and the important role they play, so that you will be able to maintain and inspect switchboards safely and securely. Switchboards are classified by voltage and by purpose. Switchboards are either low voltage or high voltage. As for purpose, they can be main switchboards, emergency switchboards, or distribution boards. We'll begin by focusing on low voltage main switchboards that correspond to the AC 440 volt low voltage power sources normally used on ships. We'll then look at high voltage main switchboards that correspond to the AC 6600 volt high voltage power sources now being adopted for newer ships. For safety's sake, the switchboard surface features what is known as a dead front. This means that the panel front does not carry an electric current. This feature protects the operator from current-carrying parts inside the switchboard. The main switchboard distributes throughout the ship electric power that has been produced by the main generator. It consists of several basic panels. This is a generator panel. It takes power produced by the main generator and distributes it to the main bus bar. The generator panel has an air circuit breaker, or ACB, that trips off the circuit in the event of overcurrent, undervoltage, or reverse power. The synchronizing panel shown here is a standard feature on conventional switchboards. This panel is used when operating two generators in parallel. However, since automatic synchronization is now the mainstream, fewer switchboards are being fitted with synchronizing panels. This is an AC 440 volt feeder panel that feeds AC 440 volt power to each of the onboard loads via the main bus bar. The feeder panel is equipped with molded case circuit breakers, or MCCBs. The wiring scheme for each MCCB is indicated on its label. Let's take a look at the inside of the switchboard and its main components. Very simply, a switchboard is a box containing wiring and various pieces of equipment. This is the input section. It receives electric power from the generator. And this is the connection section. It's found on the back of the air circuit breaker, ACB. Here you can see the ACB being drawn out from the front of the panel. The backside of the molded case circuit breaker, MCCB, is shown here. This is the front side of the MCCB. In the event of overcurrent or short circuit, the MCCB trips off and automatically stops the current to prevent damage to wires and equipment. Let's use another switchboard to take a closer look at how the MCCB functions. As you can see, lamps A through F are on, indicating that power is being fed to various pieces of equipment. Let's see what happens during an emergency stop. Suppose a fire has broken out in the engine room and that a crew member has pushed the emergency stop button. Upon receipt of this signal, the MCCB shuts down the circuit and the lamp for the emergency stop system is extinguished. Now let's consider a preference trip. When the generator becomes overloaded, the preference trip is activated and preferentially feeds power to important equipment by shutting off power to less important equipment. During a preference trip, power continues to be fed to the main systems. The MCCB is equipped with different kinds of protective equipment and measuring instruments. The fuse protects circuits against abnormal current. When a current exceeding the rated limit passes through the fuse, heat generated by the abnormal current melts a thin alloy contained in the fuse to shut down the circuit. The transformer converts the AC 440 volts supplied to the switchboard to AC 100 volts and AC 200 volts, the control voltages for relays and other important parts. The relay controls electrical equipment within the switchboard by using an electromagnet to open or close the contact. The automatic voltage regulator, or AVR, regulates a generator's voltage. When generators are operating in parallel, the regulator ensures that voltages for both generators are equal. A type of protective relay, reverse power relays, protect the generator from reverse power. Switchboards are equipped with a variety of protective relays. Please remember that when you're handling a switchboard, you are always at risk of electric shock. Electric shock refers to damage caused by an electric current when it passes through the human body. Ohm's law assigns values to the electric current flowing through the human body, which will vary according to voltage and the body's electrical resistance. The electrical resistance of human skin varies according to its wetness. Dry skin exhibits a resistance as high as several hundred kiloohms. If the voltage rises above 1000 volts, however, the skin surface is destroyed by burning, and resistance drops to as low as 0 ohms. The resistance of internal tissues remains almost unchanged, approximately 500 ohms for the area of the body between the hands and legs. Assuming that dry skin offers a resistance of 20 kiloohms, coming into contact with standard household voltage of 100 volts will send a current of 5 milliamps flowing through your body. Increase this to 440 volts and the current flowing through your body rises to 22 milliamps. This graph indicates the incremental physiological impacts on the human body of different electric currents. At level AC1, no impact is felt. At level AC2, there is no harmful impact. 5 milliamps is encountered at this level and causes no recognizable impact. At level AC3, your muscles contract, preventing you from disengaging from the current without assistance. Prolonged exposure to the current takes you to level AC4, where life-threatening ventricular fibrillation occurs. You have less than half a second to disengage at the level of 22 milliamps without significant risk of injury or loss of life. Beyond half a second, you will not be able to disengage without assistance and are at risk of serious injury or even death. If someone is being electrified, your first step is to shut off the power source. If this is not possible, then use a body rescue hook stick to pull the person away from danger. Bringing your body or an object near a hotline can cause an arc discharge, which is extremely dangerous. Modern ships often use voltages as high as 6,600 volts. You are at risk of electric shock if you approach within 150 millimeters of a hotline of this voltage. The danger gap is approximately 20 millimeters for lower voltages. Every piece of electrical equipment has electrostatic capacity. This means it's capable of accumulating and maintaining an electric charge. Conductive parts can hold an electrostatic charge even when the power source is turned off. You are always at risk of electric shock when approaching such parts. When maintaining and inspecting switchboards, you should always take measures to prevent electric shock and follow the proper procedures for safe operations. Dress lightly and properly, avoiding baggy clothing and shoes with iron hobnails. Stay away from puddles and other moisture, and never touch electric circuits with wet hands. Make sure to wear insulation gloves and remove all rings, wristwatches, and other jewelry. Put the tools you will require in a toolbox to prevent accidental contact with circuits. Store the parts you remove in a parts box after confirming their quantity. When opening a cableway, use an electroscopic bar to confirm that the cableway is not electrified. First, confirm the bar's performance capabilities. Make sure that it makes a sound when electrified, then confirm that it's not electrified. It's possible to use a multimeter instead of an electroscopic bar, but extra precautions must be taken, since your hand will be closer to the cableway. Use a grounding tool to discharge any residual charge in the cableway. Operators should cooperate with each other while following all instructions given by the leader. The leader should exercise supervision and give proper instructions to ensure safety. Each and every member should thoroughly understand each team member's duties for the day.
Attention all crew, attention all crew.
To ensure proper awareness among your shipmates, make an inboard announcement that maintenance and inspection work is underway.
Main switchboard will carry out from 1400. Thank you.
Before commencing operation, secure the operation area with ropes and/or warning signs to clearly demarcate the operation area and accessible areas. Inspections must be conducted by teams of 2 or more people, one of whom is responsible for safety watch. Use signaling and other forms of communication to maintain frequent contact among team members. When engaging in operations that require power to be shut down, post "under maintenance" and keep "power off" signs so that power is not mistakenly switched on. Always remember that accidents involving electric shock are prone to occur immediately before work is completed. Never ever let down your guard until you leave the danger area, even if your work is finished. Before touching the circuit, make sure that power is switched off. Then use an electroscopic bar to confirm that the circuit is safe. Conduct daily inspection patrols to visually search for abnormalities. Use grounding lamps to confirm which phase is grounded. Check the voltage for each phase. The current for each phase, and the frequency. Grounding lamps indicate which phase of the power system is in ground fault. Lamps for normal phases are illuminated, whereas lamps for ground fault phases are unlit. When opening the switchboard door, stay away from the electrically charged section. This is the danger area. Use dedicated equipment when conducting inspections. Due to the nature of switchboard design, polarities are classified by color according to their positions. Right or left, upper or lower, or distance from the board. Make sure to confirm polarities accordingly. A mega is used to confirm insulation levels. Locking the insulation resistance measurement switch keeps the mega switched on at all times. This is dangerous. Always unlock the switch when using the mega. The mega is prohibited from use in some sections of the switchboard. Understand where these sections are and do not use the mega there. Inspection of ACBs is the responsibility of the manufacturer. We would now like to review several accident case studies to help you better appreciate switchboard best practice. Shown here is a fire that broke out in the switchboard. Improper use of a multimeter is the likely cause. Always remember to confirm your multimeter's settings before you begin to measure. Improper use of a multimeter will not only break the multimeter, but also damage the target equipment. For example, when you intend to measure voltage, check whether the probe is inserted into the voltage measurement socket and whether the measurement range setting is correct. If a ratchet touches a terminal while you're working, you may suffer an arc burn on your hands. In some cases, your work clothing may catch fire. Short-circuit accidents can also be caused by bolts or other objects falling onto a hot line. This type of accident can be avoided by shutting off the job site power source before maintenance and inspection work begins. Use an electroscopic bar to confirm that the target is not electrically charged. Even when the job is finished, you're still not out of danger. If a wrench or other tool has been left behind in the wiring, a short-circuit accident will occur the moment power is restored to that section. Always remember to take inventory or check both tools and parts before and after carrying out the work.